Hello and welcome. Today I'm going to try to get Big Science's Bloom model, the smaller model that they created uh, to run on my M1 Mac. And yesterday I spent some time playing with this, and I had some success. And today I am trying to retrace my steps because I did a lot of things to get this working. I'm not sure which ones were important and which ones weren't, etc. So I'm going to start from scratch again today, and let's see how it goes. Let's jump over to the desktop, and here we go. All right, so this is the Hugging Face web page here for Bloom. And if you come down here, it gives model details and basics, and you can click to expand these various areas, which will give more and more information, how to train the model, and so on, uses. And so the first thing it does is it gives this information here on how to download the model. And this model is very large. This has 175 billion parameters. So it's much too large for my system. I have an M1 Mac Mini. That's not going to run. But they have a smaller model. They have a 560 megabyte model, and I'm going to try to use that. I haven't gotten it to download, but I haven't tried to use it yet. So anyway, you can take this code as a start, and there's some problems with this code. It's not going to run like this. You're going to get errors. So it also says here that this needs transformers and it needs accelerate installed. And so we're going to install those, and we're going to install some other things also. So first of all, let me go over here and bring up my why is this tiling now? Doesn't want to tile. I'll just do it by hand then. So you can see I have a Bloom directory, and I have also a Conda environment for Bloom, and I am going to deactivate this. And I'm going to create a new directory here, and I'm going to call it Bloom 2. And I'm actually going to copy here we go, bloom.py to here. So just so I don't have to type it over again. And so first of all, let's go back to here, and let's take a look at the differences. So the first line is the same. And then the tokenizer is the same. The model has been changed to from Bloom to Bloom-560M. And then device under map equals auto has been removed. And offload understate underdict equals true has been added. So these lines, this line was removed. This line I tried, it didn't help, and I removed it. But I kept it in here so that I would know that I did that. So I could put it back in. I could try it again at some other time if I experienced any other problems. So as long as I'm in here, let me copy this. And this does not copy well for some reason. And let me get out of this. And I'm going to do a loom old .py. And I'm going to insert this in here. And now let's go back and fix all the mess that this thing gets here. So you see from example, here, put a space in. I don't know why it does this. I suspect it has something to do with, here's another space that has to come out. I suspect that this has to do with my system trying to fix my syntax, because it's not this way in the example that I copied from. So I probably have some setting that I need to go and change in here. And then model equals this, and BigScience Bloom. And you'll notice here that for some reason this gets changed to a single quotes. Just click over here so you can see better. This has a double quote. I don't know why this changed to a single quote here. Rather annoying. But as I said, I think it probably has something to do with, oh yeah, it also changed it up here. I suppose that what happened, I don't know why it would change this one to begin with, but since it changed that one, it probably changed this one to close that one. I don't know. So I think that's it for those errors. And now we need to create a new Conda environment. We'll just call this one Bloom 2. And I'm using the new Anaconda for this, not MiniForge. This is the new Anaconda for M1 ARM architecture. All right, so that's done. So once you do that, then you have to do a conda activate Bloom 2. And there we go. So right now, this doesn't have anything in it. I could do a conda list here. It has the packages that were in the base, and that's it. So there's nothing in here. So first thing we want to do is a conda install transformers. And this takes a little while because there are a lot of packages in here. And so it has to resolve which packages are going to come in here so that they all agree with one another and have the best architecture. Hopefully most of them are ARM, and some will be no Arch. And that's all right. They'll have to run via Rosetta, the ones that are no Arch. But hopefully they are small. in the sense that they're not used frequently. They're not major packages. So if they're used occasionally for some little thing, it shouldn't really affect performance very much. So it's all right to have some no arch packages. And I think this is one of the advantages of using Anaconda rather than MiniForge, is that whereas MiniForge only has ARM packages, I believe, they're missing a lot of things. So you try to install something and it just says it's not available. So then you can go and try to install it with pip, and you'll get a no, maybe you'll get an ARM version, maybe you'll get a no arch version. Anyway, as I said, this takes a long time because it has to do quite a lot of work to make sure that what is being put in here is correct. And this is a big advantage of Anaconda, because if you tried to build this environment yourself, you could probably never do it. In the early days, it was a big problem, much more so than today. So we'll see that all of these things are being put in here, and some of them are OS X ARM64, and some of them are no arch. And so we can take a look at this is TQDM, it creates those little status bars that tell you your progress. Unfortunately, Transformers is coming in here as no arch, and that's a major one. I ought to see later if I can fix that and get one that is an ARM, just for ARM. Maybe if I can add the MiniForge channel here, we can get some better results. Anyway, I'm going to just proceed with this because this is what we have. I'm not going to be able to do better right now. And this, after all, is seeing if we can get this thing running. And not this is not the time for optimizing. All right, so that's done. And now we have to add accelerate. And you can see that the completion was there because it's in my history. I've done this before in the other, in Bloom, not Bloom 2. So that was pretty quick, and we got no arch again here, but PS Utils we got for ARM64. All right, so this is what it says you need, and I'm going to try to run this now, and it's not going to run. But I want to show you what happens. Python, bloom.py. And we're getting errors here. Lots of errors. So the first thing is this torch distributed doesn't seem to be there. And so I'm going to do a conda install PyTorch. Torch Vision, Torch Audio, and we're going to get it from the PyTorch channel. That's what that -C is. And let's see what happens here. And luckily here, we're getting almost all ARM64 packages, but all this stuff was missing. And so now we're going to get this. And of course, what I did earlier was I would take the error messages and I would do a Google search on the error message to find out possible solutions. Then you try those things. Sometimes they work, sometimes they don't. And then later on, I went through my history and I wrote down all the steps of the things that I did. And now I'm going through them. Some of them probably weren't helpful. Maybe we'll learn that now. So let's give this a call, a try again. See how we do. We should get some different errors now. No, this actually worked. It went through. So that's a good thing. Uh, what I should have done, I suppose, is I should have run bloom2.py, which is the version of the file before I made the edits. In other words, bloom old. This is what I should have run. There would have been other errors here from this, and those were fixed. Those were fixed by removing this device map equals auto, and also adding this offload state dict true. And let me copy this here. Just run over here, and let's take a look and see what we can find out about this statement here. You can take a look at this later. I'm going to take a look at it later. Right now, I don't want to go off on too much of a tangent here. So what happened was we loaded the 560 megabyte model, and that worked. So this was another thing that I changed. This was changed from Bloom to Bloom-560M. It was going to load the large model. That was not a problem, but it was going to run out of memory. And in fact, I think that's why I did this. I think that's why I did this and tried this, was to not run out of memory when loading the large model. And when I removed this and added this, then I was able to download the large Bloom model. And this started coming down, and I was getting the first 7 gigabytes of it, and there were going to be multiple pages of it. And I didn't want to fill my disk up, so I just hit Control-C and stopped it, because there's no way I'd be able to run that model anyway. It's just too large. I don't have the memory for it. This is just a little Mac Mini. But for this one, we seem to be good. And so now that's done. And let's go on to the next step, which is to see if we can get this going. No, not this one. Where is it? All right, so here's we want to start adding to this now. Now we'll start a new file. We've gotten this down. Let's do a vim. What are we going to call this? Generate dot pi. Generate t. Text. Generate text. Why not call it that? And so from transformers, import pipeline, set seed, and then a generator equals pipeline. And now we're going to put the kind of use for the Bloom model. So this is, I guess it's going to create this will give us a specific head, I believe, to the model. And here, we're going to change model equals GPT-2 to the Bloom model, Bloom 560M. Double check that. Is it Bloom 560 or Bloom 560M? I think it's Bloom 560M. We'll find out. We'll get an error if that's not right. In my notes here, I've got 560, but I think my notes are wrong. And now we're going to do a set seed. And set it to 42 because that's the secret to the universe. And generator. And now we'll put in the message that we want. So let's see. Let's put in just become sensitive. And we're going to do a max length. $200 tokens. Num returns. Five. Double check this. Right. That. And this should be it. This should be runnable. And we call this, what do we call this? We call this generate text. .py. All right, it didn't like this set seed. You know what I'm going to do here is I'm going to run it from an interactive Python shell here. And This, I think, will be more helpful. And the model is the Bloom 560M. All right, let's see where we are. See, Bloom. It's Bloom 560M. Maybe I need this whole thing here. Just to make it here. All right, let's try this again. Let's try it this way. That looks better. It's not giving an error, and it's taking time. It's probably downloading it again. Yeah, there we go. The tokenizer. All right, that looks good. Now let's try our seed. I don't think we're going to have trouble with this time, because it's funny how when one thing causes a problem, you get an error for the next thing. Occasionally. That worked. And then let's just run this here. Okay. Doesn't like this to be 5, wants it to be 1. And this is what it generated here. Hello, I'm a language model and I have a problem with the following code. And then it gives some code here. I don't know what this is doing. Let's try, let's change this now. Just to become sentient. And max length, let's get this max length of 200. And see what it says. Well, this is taking a while to run through this model. Just become sentient. As you know, I have a lot of things to do, and I have to go to the hospital, I have to go to the doctor, I have to go to the dentist, I have to go to the doctor. I have to go to. All right, so this is not very impressive. Let's try something else, because we can take a look at how this was trained. Let's ask a question. Question. Who was Albert Einstein? Answer, colon. So if this was trained from Wikipedia, for example, if that was part of the training set, we should get some kind of meaningful answer back. Whereas this might not have much chat information in it. Einstein was a physicist, mathematician, and astronomer. He was born in the city of Königsberg, Germany on December 1st, 1879. He was the son of a German physicist and a German mathematician. He was this is repeating this over and over again. All right, well, that's not a thrilling result, but it's working. Now, let's take a look here at the Bloom models here. Now, that's not it. Let's see. Let's look at the model card. All right, I'm not finding it. Let's look at the Bloom 560 M. I want to find the other sizes. There's 1B3. This one has been deprecated. This is one of the large ones. I might be able to run this 1B3. So let's go back to, let's exit from here. Now, I'm not sure how to get this model to cache. Uh, that's something that I'll have to look into because it seems pretty slow, but I think that can be sped up, and it may just be my lack of experience here that's showing. But I think it's heartening that we've got this working. Uh, so let's see here. Let's go back to here. Let's go to well, let me write this down. So it's 1B3. Uh, let's see if I can get back to where I had been. It's this one. No, this is not what I want. Now I'm lost. This is the one I want because this has the code. You'd think I'd be able to remember this, but that's all right. So I'm remembering that it's 1B3. Oops. Big science. I don't remember if it was uppercase or lowercase. Uh, well, if this doesn't work, then I'll know. So it seems to be working. So I'm going to need this set seed next. This is, so let's do history. Should be able to do this in reverse. I can't remember how to start up a command here, so I'm just looking for it now. ASCII top, there it is. That's what I want. There we go, ASCII top. What's the matter with this thing? ASI top. All right, so it's just not finding this, probably because it's not in this install ASCII top. This would explain why I'm having trouble, because I I installed Anaconda instead of MiniForge, and so it's not in my virtual environment here. Well, I don't want to do this. This is not the right way to do this. The way to do it is this way. So the memory usage does not seem to be horrible. We're up to 90 here, and 92%. So I put AziTop into the base environment. That way it will be available everywhere. So it'll be available inside Bloom, inside Bloom 2, uh, those Conda environments, Conda virtual environments. So I had a whole list of other things that I did yesterday, packages that I installed that I thought were necessary, and they weren't. So this is a good thing. And now I have it documented in a video so that when I forget how to do this tomorrow, I can go back and I can look at my video, and I will know, and I'll be able to make some further progress. So I apologize for these videos being long and often boring, but I do them primarily for me so that I can go back and review because this is the work I'm interested in. Uh, I don't edit them or anything like that, so sorry. I hope they help you, but it's not the main purpose. I also find that when I make these videos, later on when I go back and watch them, I see all kinds of mistakes that I made, things I didn't notice. Uh, when you watch a video, you tend to notice a lot more because it's you're not engaged in things like typing. You know, typing takes away a lot of one's attention. It's like running another process. And also speaking and so on. When you make these, it takes one's attention away. But one can go back and watch and learn a lot. So I recommend making videos of one's work to everyone. I think everyone should do this. It's just very helpful. And we're getting the tokens map. Oh no, that's done. That's 100%. So I don't know what it's doing at the moment. Oh, we're back to the prompt here. So now we should be able to set the seed. And now we can run this one again. And it will complain it doesn't like this. You remember why it doesn't like this one? It's going to complain about the 5 here. So let's change that to 1. Maybe that has to do with having set the seed. We set a seed so that we get reproducibility. All right, so let's change this from 30 to 300, and let's see if we get all those repetitions that we got before. It's really great that I can run this 1 billion parameter model. This is a large model, and this is just a Mac Mini. So this is really doing about as well as my K80 was doing. I would not have been able to have run the largest model with the K80, and I probably would have struggled with this 1 billion parameter model with it. So these little Mac Minis, these little $700 machines are quite amazing when it comes to when it comes to artificial intelligence. And I'm just thinking here that I did not run. Did I configure the accelerate to use the GPU, I don't think that I did. Although it may be that it's already in my home directory. But I should show you how that works, because you may have problems. All right, so we're getting a lot of repetitions here. Yeah, we're getting a lot of repetitions here. I was really hoping that this Bloom model was going to do better. This is not impressing me all that much. Let's see if I can get that Albert Einstein one back here. And it's also not using the neural engine. I don't know, I'm not sure how I can get it to use the neural engine. But I have something that we can try. And as I said, I did not run accelerate config for this environment. And I did run accelerate config for the old environment, and it may be that that generated a configuration file that is necessary. And so when you do these steps, you may not succeed because you didn't run that. So I'm going to show you how to run that. Let's see what this says here. So we got the same stuff as before, the theory of relativity, the first to propose a theory of special relativity. So we got some good information, and then we started getting repetitions of the same stuff. So that's not terrific, but this answer here is probably the best answer that I've gotten from a model yet. So if you run this, for example, Hugging Face's Wizard of Wikipedia model, I don't think it does as well. We can take a look at that. Well, no, this is getting to be a very long video. Let me just show you how to run accelerate config, and then we'll end this. Put this down here. Remember to put the parentheses in when you exit from Python. Accelerate. Let's just spell it right. All right, so in which compute environment are you running? 0 is this machine, and 1 is AWS or SageMaker. So you can actually run this in the cloud, run your Python program here, and have it run up in the cloud. So we don't want that. We want to run locally. And which type of machine are you using? No distributed training, multi-CPU, multi-GPU, TPU, or MPS? And I chose MPS, which is Metal. It's Apple's Metal framework, so it's using the GPU. And I think what I want to try is the multi-CPU, and let's see what happens when I do this. Does this cause you'll only be using one machine? And let's use 4. I'm hoping those are cores. And then we're going to say no for this. And now we can try to run this again. Python. And then do this. And then what's next? Let me go back to this Hugging Face code here. And we want to do the generator line next. Generator equals pipeline. It looks as though it's loading that model again. It should be smart enough to know that it's already on my system. I suppose that irrespective of whether or not it has to download it, it still has to put it up into memory. And so if earlier it was putting it into the GPU, now it's putting it into the CPU. Of course, there's unified memory on an M1, so it's the same memory, but it still has to be loaded there. I think that took a lot less time. Now we want to set the seed. We probably could skip this step, setting the seed. And now let's try this Albert Einstein question again and see what happens. And we see more activity on the CPUs, still nothing on the ANE. Now, I didn't time this the last time. I should wrap this in time. I should import time and then wrap this in time so that I can see how long it takes. Otherwise, it's going to be difficult to tell. I think that when it was running on MPS, I think it was done right about here. So maybe it's taking longer this time. But now it looks as though it took about the same amount of time. So this gave less information because I think let's run it again and see what happens. Let's see if we get the exact same thing, because earlier we got information about his parents, and that doesn't appear to be in here. And I think about his town, I think that was in here. And then we'll finish up, because now you know how to run accelerate config. And I can also try giving this seven or eight, even 8 CPUs, because I have 8 here and an 8 cores GPU. It really bothers me that the ANE is not being used here. Of course, it may be this tool. This tool may not be working properly, the AziTop. This is the only tool I was able to find that does anything about the ANE. But it may not be very good. And in fact, the author of the tool says this, that it may not work all that well. Apple has made this ANE a bit of a mystery. It certainly has not been has not been integrated into their analytic system monitoring. I forget the name of that. Where is this? Activity monitor. I don't know why I have trouble remembering activity monitors sometimes. But yeah, activity monitor does not have any integration, doesn't tell you anything about the ANE. So just not helpful. As I said, ASITOP is the only one that shows anything about this, but at the moment it's not showing. All right, so what happened here? So it didn't give more information, it just kept giving the same information. What about if I set the seed to something else here? I was going to end this, but why not try something else? And I'm generating a long string here, 200 tokens. And of course, it has to do statistics for all those tokens, so it takes a while. As I said before, the reason we set the seed is because we want to be able to have the same things happen over and over again, so that if we make changes to the system, we can tell things about the timing, etc. I need to add TQDM to this so that we can start to take a look at how we're progressing. All right, so yeah, this is not giving anything particularly wonderful here. So you see that when we ran this on the smaller model, we got this information about being a physicist, a mathematician, astronomer, born in the city of Königsberg, Germany, etc., etc. So I don't know. I think this was, but it didn't mention the relativity and general relativity. So not great. Neither model, I think, is doing particularly well. This is giving interesting information. The other one is giving interesting information, but you would think that it would give an answer without all this stupid repetition. All right, so I'm going to end this video now. I hope you find this helpful, and I hope that if you make more progress with it, that you will, if you make more progress with this, make a video, post it online, help the community so that we can all advance together. Go ahead and like and subscribe and all that kind of stuff. And thank you for joining me.